Okay, let's look at these problems. Let's look at 32 here. A wrecking ball, similar to the one shown in the diagram, has a mass of 315 kilograms. It's moving at a speed of 5.12 meters per second. What's its kinetic energy? Well, we have a formula for that. 1/2 m times v squared. So that equals 1/2 times a mass of 315. And then we take 5.12, which is the speed, and we square it. That equals 4,129 joules. But looking at the sig digs of the problem, 1, 2, 3, 1, 2, 3, our final answer should have 1, 2, 3 sig digs. So we'll need to write this as 4.13 times 10 to the power of 1, 2, 3. So 4.13 times 10 to the power of 3 joules would be the final answer in that case. For number 33, we have a freight elevator. It has a mass and a speed. What's its kinetic energy? EK equals 1/2 mv squared. That's 1/2 times a mass of 120 times speed of 2.5, which we're going to square. That equals 375 joules. 3 sig digs in the data, 3 sig digs in the data, 3 sig digs for our final answer, so we can just leave it like that. Number 34, a student has a mass of 55 kilograms and has a speed of 1.6 meters per second while jogging. What's the student's kinetic energy? Same thing. Use the formula and substitute the values into it. That's 1/2. The mass is 55 kilograms. The speed is 1.6, and we're squaring that. That equals 70.4 joules. But since our data only has 2 sig digs, our final answer should only have 2 sig digs. So we'll go with 70 joules. And then finally, number 35. An electron has a mass that's very small, 10 to the negative 31, and it's moving at a speed that's very fast, 10 to the 7 meters per second. If we're looking for the kinetic energy, doesn't matter if the numbers are huge or tiny, we use the same formula. And that kinetic energy equals 1/2 times m times v squared. That's 1/2. And the mass is 9.11 times 10 to the negative 31. And the speed is 2.19 times 10 to the 7, which we're squaring. For scientific notation on your calculator, remember to use that exponential or EE function on your calculator. So what I would do in that case is I would have 1/2 or 0.5 times 9.11, and instead of writing times 10 to the power of, I'll use the EE button, which comes out as an E, and that's to the negative 31 for mass. Remember, this means times 10 to the power of. So this is 9.11 times 10 to the power of negative 31. And then I'm going to multiply that by 2.19. Again, with the E button, times 10 to the power of 7. And then we're squaring that. So that was a kinetic energy of 2.18 times 10 to the negative 16 joules for your final answer in that case. Looking at 36, a basketball is moving with a speed of 6.1 meters per second, has a certain amount of kinetic energy. What's the mass of the basketball? Start with your kinetic energy formula. And what are we trying to find? We're trying to find the mass. So we have to isolate for m. So to isolate for m, we have to get rid of this 1/2. How do we do it? Multiply by 2. 2 times 1/2 is 1. It gets canceled out. Mass is being multiplied by v squared, so we have to divide by v squared. V squared divided by v squared is also 1, so it goes away. So now we're isolated for m, but whatever we do on one side of the equation, we do on the other. So we must multiply by 2 and divide by v squared on the other side. Our equation turns out to be 2 times EK divided by v squared equals the mass. And now we can just fill in the numbers. Mass equals 2 times kinetic energy of 8.4 divided by a speed of 6.1, and remember you're squaring that speed. Plugging that all in the calculator, we get 0.45 kilograms. 2 sig digs in my final answer that match the 2 sig digs for my data. Number 37, a bowling ball has a certain speed and kinetic energy. Again, what's its mass? So let's practice this. Kinetic energy equals 1/2 times mv squared. We want to isolate for m. Multiply by 2, divide by v squared. 2's cancel out, v squareds cancel out. Do the same on both sides. 2 divided by v squared. Final equation is m equals 2 times EK over v squared, and filling in the values, that's 2 times a kinetic energy of 15.7 divided by a speed of 2.21, which, don't forget, you're squaring, and that's 6.429 kilograms. But since our data has a minimum of 3 sig digs, we should only have 3 sig digs in our final answer, so it should be 6.43 kilograms. For number 38, we're looking for speed, and we have mass and kinetic energy. We start with our equation, and we want to isolate for speed. So what we're going to do is multiply by 2, that gets rid of the half, divide by m, that gets rid of the mass, and we do the same on both sides. Multiply by 2, divide by m. Your equation so far then is 2 times EK over m equals v squared, and we know to get rid of the square, we square root. And we have to do that on both sides. So our final equation becomes v equals the square root of 2 times, I'll write this bigger, the square root of 2 times EK over m, and we fill in those values in the question. 2 times the EK of 12 joules divided by the mass of 0.155 kilograms. To 3 significant digits, that becomes 12.4 meters per second. Just scanning the next 2 questions, we're asked for how fast, so we're looking for speed, and since it's connected to kinetic energy, we can use this same equation. We already isolated for speed here. So if you need practice being able to isolate for speed, you can go through the whole process for questions 39 and 40. But for me, we've given that example. If you need help with it, you can rewind. So we'll just use that equation for speed already isolated. So for 39, again, we're looking for speed and we have kinetic energy and mass. We came up with this equation, 2 times EK over m, and we'll just fill in the values. That's the square root of 2 times a kinetic energy of 75 joules divided by a mass of 115 kilograms. Our final answer in this case should only have 2 sig digs, because while the mass has 3 sig digs, the amount of energy only has 2 sig digs. Our final answer then should be 1.1 meters per second. Finally, for 40, we're going to use the same equation because we're looking for speed while we're given kinetic energy and mass. 2 times EK over m, which is 2 times the kinetic energy of 77 times the mass of 15. and to 2 significant digits, the final answer then would be 3.2 meters per second. Okay, hope that helped. If you have any more questions, please email me or just come to the tutorials online Tuesdays and Thursdays at 1 p.m. Thank you.